Hello everyone. Today we're gonna talk about the homework 7 and question 7. Now let's look at the question first. It says we have this equation and this, and the question tells us we have these two as well. Now they ask us to find the EZT. So first thing, when we know these two are y-sense stationary, then we can say then we will have this property in here. That means these are constant, which is for 2 as well. So it's for n2 as well. n1 and n2 for this is a constant. Now let's write the expression for EZT. We can expand this thing to looks like that. We can expand it. Well, after we expand this equation, we can solve it easier. So, and now we can write the following as these. That means we put the E on both sides. You can see that. The other thing else is still the same. After taking this equation in here, now we can say take the derivative of both sides for these two parts. Then we will attain here this equation here. The 2 pi to 0 is for the theta. We already know according to the question. So in here we are taking the integral of these two parts. After taking the integral, we can have the results for this question. So in here, after we taking the integral, we will see is eta times 0. So this result becomes 0. That means the EZT is 0 in here. Now let's look at the part B. Part B asks us to find R, C, T1, T2 and determine its CTWSS. So for the RZ, T1 and T2, we can write the expression as following, as like this. Look, which looks like that. Then we can expand this equation to make it look like this, which is kind of similar to the last part. Here is N2, no. So I'm keep writing in here because this is a very long equation. For this long equation, all we need to do is similar to the first part. It's a long equation in here, so I'm gonna do it concisely. Since we already know this part, which is this part in here, this part in here, we know this part is equal to Rn tau times E the cosine this thing in here. Let me write this completely so we can see that more clearly. Since we already know this equation is equal to the expression here, so we can calculate this both equation, and the result looks like that. It looks like 1/2 times the Rn 1 tau Rn 2 tau, and the cosine, which so the part 2 looks like that. Now, so we can say the ZT is WSS. Now let's look at the question C. The question C asks us to find the RZ0 when we under the condition if ZT is WSS. So in here we need to simply plug in things we already calculated that in the previous part. So here we just plug in the 0 in 8. Then we can find the expression for this question. So the results for this question is here. And that's pretty much how we solve this question. And thank you for listening.